Okay, this is the whole thing. This is the hardest problem that we're going to do. Okay, this is going to have an x expression. It's going to have a y expression. And it's going to have a torque expression. Okay, if we add up all the forces in the x direction, they add to 0. All the forces in the y direction will add to 0. And all of the torques will also add to 0. Okay, now let's see. Let's draw some arrows here. Okay. Let's just start at the left side. Okay, let's assume that the wall here, that little point right there, okay, the wall is exerting an upward force and that the wall is exerting a force to the right. Okay, I always guess up and to the right, and if I'm wrong, I'll get a minus sign. Okay, and those are acting at the left side, so at r equals 0. Okay, so I've tacitly assumed I'm going to pivot about this point, which I think you should do. You could pivot about this point as well. It doesn't matter. I always just pick this because I think it's simpler. Okay, then we've got the beam is 2 meters long. I'm sorry, the beam is 4 meters long, so therefore the center of gravity is at 2 meters. Okay, so at the center of mass is right there, right? The force of gravity is acting down, and that's going to be a force of 12 times 9.8. So that's what I mean by that. That's 12 times 9.8. Okay. And then that's at 2 meters from the left side. Then we've got this guy here. I'm just going to try to see if I can draw this. Usually I fail, but let's just see. Oh, it's so hard. Okay. So that's the tension in this cable, right? And of course that tension has a first name, it's OSCAR. No, I'm just kidding. That tension has a horizontal component, right? Okay. So this is, what is this? This is 30 degrees, right? This is T sine 30. Is this component right there. And then this component down in there is, that's T cos 30. Okay, now where am I getting that? That's from SOHCAHTOA, right? This is the side opposite, so it's sine. This is the side adjacent to this angle, right? So therefore it's cos, okay? So T sine theta is this one, T cos theta is there. This will pitch into the X formula. This will pitch into the Y. It also does torque, okay? And then, of course, we've got a force of 5G at 4 meters, right? And that's what we've got. We've got the force the wall's exerting in the X and the Y, the tension, the force of gravity acting down, and then this guy down, right? So let's set up our X expression. We've got the wall in the X direction, right? And then this guy looks to me like it's pointing left. So I'm going to say minus T cos 30. Okay, so that's minus because it's pointing to the left. Okay, see that? This component to go from here to here is definitely a leftward component, right? And that, by the way, that's all that happens in the X direction. This cable's got a component of force pulling it toward the wall. The wall obligingly pushes back with the same force. And then those add to 0. Okay? And then our Y direction here, let's see, what do we got? We've got the wall in the Y direction. So there might be an upward force, or it could be downward. The wall could be pushing down. Right, especially if this is heavy enough, right? All right. Then we've got the next force is 12G acting down, so minus 12G. That's minus because it's down, right? Then we've got the part of the cable lifting up, so plus T sine theta times sine 30, right? All right, and then the next one is the weight of this guy down, so minus 5G. Right, now we have two unknowns. We got the wall in the Y direction and the tension. So this cannot be solved, and this cannot be solved, right? And what's going to happen is we're going to solve for T in the torque expression and then just substitute it in. Okay. All right, so let's go. Let's see, torque. Let's go about OU, about the left side. Okay, so let's torque that sucker. All right, let's see. The wall in the Y direction, but it's at 0. So 0 times wall in the Y direction. The wall in the x direction, by the way, doesn't exert any torque because it's parallel to the thing, right? The next one we've got is a clockwise torque due to this guy, so plus, and how far out is that? It's at 2 meters, right? That's because it's a 4 meter long beam, so it's 2 meters times 12 G, and that G is 9.81. That's what I mean by that, right? All right, I'm just trying to keep things civilized here. Okay, and then we've got an anti-clockwise torque due to this component right here, the T sine theta, right? So minus, and this is 2.3 meters out, right? So minus 2.3 times T sine 30. Okay, now, by the way, you could also get that torque by just doing, remember, torque is RF sine theta if there's an angle. So I could have gotten it from the formula RF sine theta. I could have gotten it by looking at this component. It's really the same thing. And saying that that component is the one that makes a torque and this one doesn't torque. It doesn't twist the thing, right? Okay, so let's see. We've got this guy exerting 0 torque because it's at the torque point, at the pivot point. We've got gravity doing a clockwise torque. The cable doing an anti-clockwise torque. We just have to do this guy, right? So plus 4 meters times 5 times 9.8, 5G, right? And then that's 0, okay? Now, because we, of course, picked the spot where the wall is acting on it, right? This drops out. This now is solvable for T. So let me solve that. What am I going to do? I'm going to go 2 times 12 times 9.81. And I'm going to add plus 4 times 5 times 9.81. Got those guys. And then I think, let's get that answer. Let's divide that by 2.3 and divide that by the sine of 30. What mode am I in? I'm sure I'm in the right mode. Sine of 30. I'll find out here. I've got the answer. 375.339. Yeah, there it is. The answer is right there. So the tension is 375.339 newtons. And tensions are always tensions. They're always positive numbers because it's very hard to push with a cable. Okay, so that's, I've got the tension now, right? And now I need to find the wall in the x direction. So let's do that. All right, so we go wall in the x direction minus 375.339 cos 30 equals 0. So I'm going to multiply that by cos 30. 325. So wall in the x direction is 325. And the fact that it's positive, of course, means it's to the right. All right, now we got to solve for the wall in the y direction. Okay, so let's set that bad boy up. Wow. All right, here we go. Okay, so wall in the y direction minus 12g plus, what is our 375.339 times the sine of 30, right? Minus 5g equals 0. Okay, so I take this number, right? Plug it in here, right? And then there's only one unknown, and then we can solve for that, right? All right, so let's figure out the wall in the y direction. So I think what I'm going to do is I'm going to do this guy. I'm going to go 12 times 9.81, and I'm going to go add 5 times 9.81, and then I'm going to subtract 375.339 times sine of 30. I'm doing maths here is what I'm doing. Minus 20.89. So 89956 newtons, right? So the wall in the y direction, the minus means down, right? So I'm going to say, and you need to do this, you need to say 20.9 newtons down. So if you're an engineer designing this, it won't do to to have something here where it just rests on top of something. You've got to have something that can actually exert a downward force on it, like a hinge or a bolt or something like that. Okay, and then the reason is that this mass is far enough out that this thing teeters about this point, and if you didn't have a downward force, this thing would actually flip up like that. Okay, I hope that makes sense. All right, so what did we do here? I drew a picture of all the forces acting on it. Okay, so the wall and the y, the wall and the x, right? Okay, that's so when we have the wall, it's just, just assume that there's some force in the y and some in the x. Assume that they're up and to the right. We've got the tension, which we broke down into tension vertical, tension horizontal, right? We've got the force of gravity, which acts at the center of the beam, right? Okay, straight down, and the force of gravity on this, straight down wherever that thing says it's attached. We set up an x expression, added up all the x's, set them to 0, add up all the y's, set them to 0, add up all the torques, and I always pick the left side. Okay, or in general, if you're solving these problems, pick a spot where one of the unknown forces act. I could have also picked this spot right here to torque about. Okay, but anyway, there you go. Happy hunting.